Okay, so this video is going to teach you even more about the average atomic mass. We know that an isotope is an atom with the same number of protons, so it's the same element, but it has a different number of neutrons. And because neutrons, the function of neutrons is to control the mass, changing the number of neutrons changes the mass number of your isotope. Now, as you've noticed, the elements on the periodic table are not whole numbers. And that's because they are averages of the isotopes that occur naturally in different abundances. So just like when you're thinking about your grades, in some classes your grades are weighted, so your tests and quizzes are worth more than your homework assignments. The same thing is true for the different isotopes on the periodic table. So an isotope that occurs more often is going to be weighted more than an isotope that does not occur as often. And the next example, you're going to see what I mean, okay? So when it says to find the average atomic mass of chlorine-35, this chlorine-35 right here, that tells you, that's another way to write our atom. You know that chlorine has 17 protons, and so this 35 is telling you the mass number. And remember, the mass number is the neutrons plus the protons, so we know that this must have 18 neutrons in it. So this is just another way to label the different isotopes that you have. So chlorine-35 has this particular mass. Now remember, this is the exact mass. So this is all the protons, all the electrons, and all of the neutrons in it. Chlorine-37 has a mass of 36.966 AMU. Chlorine-35, as you notice, accounts for 75%, and chlorine-37 is 25%. So of all the known isotopes of chlorine, you get a 75% chance of getting chlorine-35 and a 25% chance of getting chlorine-37. When you're finding the average atomic mass, you want to take the mass times the percent, but notice how the percent has been changed into a decimal. So when you take that, you get 26.23. You're going to do exactly the same thing with chlorine-37. So you're going to take the mass times the relative abundance, and that's going to give you 9.24. And the whole reason why you're doing this is because at the very end, you're going to add those two things together to find the average atomic mass of chlorine. So if you were to go to the periodic table, you would notice that the mass on the periodic table of chlorine is 35.47. And now you understand where they get that number from. What I would like for you to do is I would like for you to pause the video right now, and I would like for you to try to work out this problem as you go. So try to work this out on your own. You'll need a calculator. And then after you pause the video and after you work out the problem, then play the video again to check your work. Pause the video. Okay, so now that we've come back, hopefully you guys have tried this problem, and now we're going to figure this out on our own. Okay, so the very first thing is 15.995, and that makes up 99%. So that's 0.99757. And when you put that into your calculator, you are going to get 15.9561. And you can keep as many decimal places as you want to. Okay. The next one has a mass of 16.999. And you're going to multiply that times its relative abundance, which is really, 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 really small. So please, please, please be careful when you're taking this to a decimal, because even though it's already in a decimal, you still have to move your decimal place 2 times. So this is actually going to be 0.00038. So that's going to give you 0.00646. And then it looks like there's another one where it's 17.999, and that makes up 0.2%. So again, when you move your decimal over 2 places, and you got to fill in with a 0, That's going to be 0.00205. So that means that these two isotopes of oxygen don't really exist, and that this is the main isotope of oxygen. So we should get, at the very end, we should get a mass that's very, very, very close to the 15.995. Okay, so again, 17.999 times 0.00205. That's going to give you 0.36897. And at the very end, you're going to add all of these numbers to give you an atomic mass of 15.999 AMU. Okay? And again, this is what you will find on the periodic table. Thank you for watching.